This video is about precipitation reactions and solubility. So it turns out that many compounds do not dissolve in water. If you try to dissolve them in water, they will literally just float around or eventually sink to the bottom. Okay, and if we form them in solution by, say, adding the two compounds that form them, a solid will form spontaneously. That is called a precipitate. Okay, so we can see down here, somebody is adding a clear solution to a clear solution. So each of these has something dissolved in it. When we mix them together, we bring together two things that are not soluble. When they're together, they will find each other, form a solid. It will then sink to the bottom. All right, so how do we know whether or not something's going to precipitate? Unfortunately, there are just some rules to learn. I'm not going to be super picky on you learning all of these perfectly right now. It's not going to be a huge focus of this course, but you should at least be aware that there are these solubility rules. Some things that are always soluble. These first couple are very, very simple, and you are going to be responsible for this for sure. Okay, so cations that are always soluble, the group 1As. So if you see a group 1A cation with any ion, it doesn't matter what the anion is, it is soluble. Okay, same for also ammonium. So ammonium, sort of group it in with the group 1As. Those cations always soluble. If you see them, that is a soluble thing. Anions that are always soluble. Nitrates are the most common. We don't honestly see bicarbonates or chlorates or acetates, which are the other three. Bicarbonate, acetate, chlorate, of course, in that order. Really, the one I want you to focus on is nitrates. Nitrates are always soluble. Then we have some anions that are usually soluble. The halides, except for fluoride. Notice fluoride is not on this list. It's a separate thing. The halides are usually soluble, except for with silver, mercury, and lead. Fluoride is also usually soluble, except for group 2As, lead and iron. And sulfates are usually soluble, except for kind of that large list: silver, mercury, lead, calcium, strontium, barium. So it's kind of most of the group 2As, along with the silver, mercury, lead. So silver and mercury and lead, if you see those, they are very likely to be insoluble. Of course, if they're with a nitrate, not true. Okay. Same with the group 2As. Most of the group 2As are insoluble unless they're with something like a chloride or a bromide or nitrate. Insoluble things, basically, you know, because it's not on the soluble list. Some things that you may see frequently, really OHs. OHs are very common. They're only soluble with those always soluble things, plus barium. Okay, barium, for whatever reason, barium hydroxide is soluble. There are chemical reasons for this. They are a little beyond the scope of this course, which is why we teach this kind of just as you have to learn it, which is why I don't want you to get too overwhelmed with it. Okay. Other things that are frequently seen and are only soluble with those always soluble things: carbonate, phosphate, chromate, and sulfide. So again, sulfide, don't want to worry too much about that. Carbonate and phosphate we will see a lot, so you should definitely know if you see carbonate and phosphate, unless it's with sodium or ammonium or something, insoluble. Okay. So the way we can use this is, well, let's say we're going to try to predict whether or not something precipitates. Okay. The other way is I can simply say, is this thing soluble? But for precipitation prediction, we'll talk about that. So will mixing lead 2 nitrate and sodium iodide form a precipitate? And if so, write the net ionic reaction. Okay, so first thing, we need to write down what we're even starting with. Okay, and then what we're going to do is we're going to switch anions to see what products could possibly form. Okay, so we write down lead 2 nitrate and sodium iodide. And then we switch the anions, so we see that we have lead 2 iodide and sodium nitrate. Okay, so the fact that the first two are clearly soluble right away can sometimes help you remember some of your solubility rules, right? Lead is one of those things that is frequently insoluble, but clearly it's soluble with nitrate here on the left-hand side. That's because the nitrate's one of the always soluble things. Okay, sodium iodide, sodiums are always soluble. So we've got the possible reaction here, the possible molecular reaction. At this point, I just want to say here, you don't need to worry about balancing the reaction. You're going to be crossing most of the things out anyway. So really, it doesn't really matter at this point whether you're making 1 or 2 of something or whatever. What you want to know is what you could be making. Step 2 is using solubility rules on the product to determine if either of them might be insoluble. Sometimes they're not. Sometimes you're just like, nope, there's no precipitation here. So lead iodide, first of all, iodide is usually soluble, but lead is one of those exceptions. So lead iodide is actually not soluble. It will form a solid. Let's just check sodium nitrate because sometimes I am mean and I give you 2 things that precipitate. However, sodium nitrate is super soluble because if you know either of the rules, so sodiums are always soluble and nitrates are always soluble, so definitely sodium nitrate gonna be soluble. Okay, so the net ionic reaction then is the 2 ions that form lead iodide. This is the point where you want to balance it, but at this point it's relatively simple. Okay, so lead 2+ plus 2 iodides makes lead iodide. If I don't do write out, lead 2 nitrate, okay, make sure you're, using the right thing. And make sure you do balance these things. You don't want to write out that you're going to form, say, PBI. Okay, PBI would be lead 1 nitrate, or sorry, lead 1 iodide. We don't want to do that. So make sure you're using your naming that you already know to write the right things. Okay, so that's your net ionic equation, and that's what we want for the final answer. And that's the end of this video.